Okay, so here we have another example. This time, instead of giving us a formula for the terms of the sequence that are being added up, we're just given a sum. And so we actually have to decode that and figure it out. But we remember our idea, right? The first term, that's our A. So A is 1/4. So I'm going to write everything here so it's in terms of 1/4. So the first term would be just 1/4 times the ratio to the 0 power. And then I'm going to take the 1/4 and factor it out of the 1/12. So that would be 1/4 and times 1/3. And then for 1/36, that would be 1/4 times 1/9, but 9 is just 3 squared. So that would be 1/3 squared. And the same thing, 1/8, take out the 1/4 from it. Then we'll be looking at 108, taking the 4 away, leaves me with a 27. Right, that would just be 1/3 cubed. And so on through all the terms till we get to the last one, 29/16. So 29/16, let me take the 4 out of that. That leaves me with 729. 1/4 times 1/729. And now I'm going to see what the heck is 729 in terms of 3. So we already know 3 cubed was 27. 3 to the 4th is 81. 3 to the 5th is 243. 3 to the 6th is 729. Okay. So that 1/729 would be the same as 1/4 times 1/3 to the 6th. Right, they all have to fit that pattern. If that didn't fit that pattern, then this wouldn't be a geometric sum, and I would have to just pretty much add them up. But it has to fit the pattern, otherwise, what are we doing here? So that I can just write that as 1/3 to the 6th. And so we recognize that what we're really adding is the sum. So now we recognize A is 1/4, and the ratio is 1/3. So we're really dealing with the sum as k goes from 0, and the last power was the 6th power. So to 6 of A 1/4 times 1/3 to the k. Times 1/3 to the k. And so that is just S7, the 7th sum. And so now we can use our formula. That's A times 1 minus r to the n. So 1 minus 1/3 to the 7th over 1 minus 1/3. Okay. Now this is small enough that I can actually get away with doing it on a calculator and having it convert back to fractions. Of course, we could do this in our head as well, right? 7 to the 3rd power, 3 to the 7th power is 2187. So that numerator is going to be 1 minus 1/2187, which would simplify to be 2186. And then the 2186 is going to be divided by 8/3. So it's 2186. It would be 2186 divided by 2187, right, in the numerator. And then that would be divided by 4 times 2/3, or in other words, 8/3. Okay. And this one, my calculator will actually spit out okay. It doesn't lose any accuracy. We could again do more of that by hand, simplify some stuff, but it's 1093 over 2916. 1093 over 2916. Okay, and so Now we have our sum worked out. Okay. So what we're going to turn to next is the infinite series. Now you might be thinking, wow, this geometric sums were a pain. Geometric series is actually going to be harder, right? Well, it actually turns out the formula for the times that it will converge, the geometric series, is actually going to be easier to work with than the geometric sums, as we're going to see. We'll discuss that in the next video.